All right, so I'm live with 52 weeks of Rust. Last week, I covered getting started with Rust. So, some very basic things like not anything very complicated, but so far I'm pretty impressed actually with Rust. And if I remember correctly, probably the biggest issue that I've had so far with Rust is that the cleanup of the binaries is something that's kind of messy. And I guess it really is always the same with any language. Like when I was doing things with Erlang, the Erlang binaries, like, okay, well, where do I put them? Or C sharp. There are some issues with do you create a make clean, or like what are the best practices? So I figured that might be a good place to cover things in the next few weeks, is to make sure I've got that covered. But I also could continue to just go through the language. If it comes up and I find an easy way to clean up my project structure, I'll definitely do that, like put them into a bin directory or something like that. But I'm going to just keep going here on Rust here. So let's go ahead and create another GitHub location. I'm going to go ahead and share this out. Here we go. All right, so I've got GitHub here. Perfect. And I'm going to open this up a little bit more. There we go. Got this. All right, so in terms of Rust, where I left off with is this 52 weeks of Rust repo. And in particular, what I was going to focus on is really continuing the example guide here. I think was probably a good place to continue with. So notice that before I had a repo that was connected to GitHub Codespaces, and because it's connected to GitHub Codespaces, I can go through here and build out things directly inside the web browser, which is pretty nice because it enables me to not have to set up a local development environment, especially for a new language when you're not totally comfortable with it. There's a lot to be said about going through and using like a code-based, a browser-based environment, or a cloud-based environment. So I'm going to go ahead and here and go file, terminal, and get this running. So now I think a good place to continue to work here would be to potentially figure out what to do with these binary files. I mean, that is a little bit irritating, and I guess I could try to figure that out. But let's keep going on the Rust language getting started guide here. So I think I was at learn, and I think we were here. Yeah, okay. So I was in Rust programming language, and I got, I think, into, for sure, we got through hello cargo and variables and mutability, programming guessing game. Okay, here we go. What is this? So let's jump into Rust by working through a hands-on project. This introduces you to a few concepts by showing you how to use it in a real program. So you do a cargo project. So to set up a new project, go to the projects directory and make a new project. Okay, well, let's go ahead and try that. So I'm going to go ahead and say, in fact, cargo, new guessing game. Let's go ahead and do that. All right. And so this maybe is the answer here, is that when you go through here and you create a new structure like this, that this may be the way that we're able to handle these binary files. So I may have solved the problem by just learning more stuff. And then we're going to cd into this directory. Okay, let's go ahead and do that. And let's look at the generated cargo.toml file. See more keys and their definitions, guessing games. All right. So we see that it's got the version, the addition, and Cargo new generates a new program for us. So it should have generated a hello world. Okay, let's go ahead and check that out. So if we go through here, source, okay, there we go. So it generated hello world. And now to compile it, we're going to do the same thing. We're going to say cargo run. Okay, so we're inside of this directory here. And let's go here and we'll say cargo run. So I guess the trick is that this 2ml file needs to be in this directory. Perfect. Okay, now the first part of the guessing game program will ask for user input, process that input, and check that the input is in the expected form. To start, we'll allow the player to input a guess. So we're going to basically put this inside of here. So this is a kind of a classic command line type program where you ask the user for input. In this case, we're going to say put in a number. This variable right here is going to create a new string, and then we're going to use readline, and then we're going to pass it back in. So this is a good example of what you would do in many languages to play around with it and get more familiar with it. So here we go, use stdio, guess the number, input your guess, failed to readline, and you guessed it, perfect. So let's go ahead and go to the next step here, which is that, well, again, this is using the standard library, and this is how we create a function. That looks good. And the story of the values, in this case, we're using a mutable variable, which is making a new instance of string. And then in this case here, if you use just let, it's immutable. So all this looks good. And then this is the receiving user input, which is pretty cool. And then we also have the ability to handle exceptions, a potential failure. And now if you don't call expect, the program will compile, but you'll get a warning. I see. This may result in an error variant. This should be handled. Oh, that's pretty interesting. So Rust has some smarts in here that enables you to write good code, which I like. So let's go ahead and say cargo build, and now it's going to go through finished, unoptimized target. There we go. And now we can just run our program. And so this is the string substitution. Okay, so we'll just say cargo run now. So we'll say cargo run. Please guess the number. There we go. You guess 15. So that actually is a really cool program. I think it covers, the author of this really did a great job at giving you some ideas of how to play around with Rust. And again, you're using the standard library, you're writing a function, you're accepting user input, you're creating a mutable variable, and you're also handling exceptions. And I guess we could try that. Like let's go ahead and see what happens if I comment. Is this how you do a comment in Rust? Oh no, we'll do a double slash here. And let's just build it again. And they're right. There we go. Expected this, but found enum results. And it says that could not compile in this particular scenario. Oh, because we needed. Let's put that on there. We're missing a semicolon. It should have been a warning. Okay, there we go. A warning. It says unused result that must be used. And this result may be an error variant, which should be handled. So that is nice. The compiler is really helpful here in telling us that our code is really not the greatest. So if I go and I uncomment this back out and I build it again, we should be able to build with no errors. right? So pretty cool. And went through the guest here. So let's see now. How would I check this in to our GitHub project? So let's see if I can figure this out. So we have the I see here target debug. So basically, I see what's going on here is that once you've created a cargo project, it creates a logical structure that, in fact, does it create a get ignore or no? I wonder if let's go ahead and take a look at our get ignore here and see what happens. Okay, removes cargo lock. These are back file. This generated by cargo. These will have compiled. There we go. So this is. I should have just read the get ignore. Like these people that wrote Rust are smart. They probably figure out a way so that you don't check in compiled files, and there we go. That's exactly what it is. So what that means is if I want to check in this repo, what I need to do is I'm going to remove the binaries. So anything that doesn't have the .rs in here, I'm gonna get rid of. So I'm gonna say rm hello. That was a binary. I'm gonna remove hello p, and I'm going to remove primitives. Now if I say get status, what do we got? We have those. Okay, let's say get add star. And now if I say get status, what do we have? I don't like that. Why is it trying to check in those? That's not good. It should have, I guess the difference here is that I need to tell it about all targets, not just the target that was in my current working directory. So if I go back to my get ignore here, and I say target, these are backups. Yeah, see, I'm not sure why that's not, let's say Rust generic get ignore targets. Let's see here. Executable crates. But why? We want a smarter one, so it can be a symlink. Fair enough. Let's see. Perhaps. Yeah, there may be. We're still. This is going to take me a little bit to figure out how to not check in garbage. I'm getting closer. And so, let's see. Like git reset, add, undo. To get add before commit, run get reset, or to unstage all changes. So let's reset. So let's say get reset the guessing game, and now I'll say get status. Okay, now the how do I tell it in this scenario? I don't want anything in the target, and so I think what I can do, I guess I'll just have to put this inside of there. I'll just say guessing game target. So if I do this, if I say go up here and I say vim get ignore, and then I do this guessing game target, what happens? If I say git add guessing game and I say get status, there we go. This looks much, much better. So I guess there probably is some super fancy way to like write a regular expression where I could get rid of all targets that are created indefinitely. But for now, I just know if I create a new project using crate, that I'll need to actually go into my get ignore and I'll need to set up a message here. So I feel happy. I mean, I learned one cool thing today about Rust, which is how to not check in binaries, which is a huge win. So adding new projects without checking in binaries. That's a huge one. Okay, so we did some fun stuff with Rust here, and what we can do is actually play around with. Keep going now. Now I feel pretty powerful that I can actually build something potentially useful now that I got past that really big problem. And so I'm going to keep going on the guessing game stuff. So it says use a crate to get more functionality. So remember, a crate is a collection of Rust source code files. That's great. The rand crate is a library crate. So yeah, I like random standard library. I use it all the time in Python. And the cargo coordination of external crates is where cargo really shines. Before we can write the code, we need to modify it to include the rand crate as a dependency. Oh, okay, that's pretty cool. So we just put this inside of our cargo.toml. Wow, that's very interesting. That's how they do things. Okay. Now I know a new thing. So we do this, which is very weird. I mean, I guess for a standard library though, it seems strange, but interesting. And then in the cargo.toml file, everything that follows a header is part of the section. So okay, let's build it. So we'll do cargo build. So next up, let's say cargo build. Because I need to be in the right directories. I need to be into guessing game and do cargo build. There you go. So now it's going to grab the random, and I guess maybe random is maintained by some third-party person. That's why we have to use this crate system. So it's not built into the standard library. Okay, so I answered my own question. That does make sense. And in fact, it's nice that Rust includes something like cargo. I'm assuming it's basically built into language. I don't know yet, but if so, that's a huge advantage because Python doesn't have built-in package management. Okay, we see this, and you can see different version numbers. We may include internal dependencies. So cargo fetches the latest versions of everything that a dependency needs from the registry, which is copy, blah, 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 blah. Wow, really cool. So the ensuring reproducible builds with cargo lock. So cargo is a mechanism that ensures you can rebuild the same artifact every time you or anyone else builds your code. Cargo will use only the versions you specify. Perfect. Okay, updating a crate to get a new version. Cargo update. So if you wanted to go to, let's say, if the RAND has released 2 new versions and you want to use the following, okay, let's try it out. So let's go to RAND 0.90. Wow, I'm like learning everything from this tutorial. Whoever wrote this tutorial is really, I think, a good author. I like what they're doing. So cargo update. Huh. Failed. Oh. Weak. Let's see. To use RAND version or any version. Oh, next time you run cargo build, I want to look for versions. So let's try one more time. Let's say cargo build to select a version which didn't match requirement package. Huh. Well, let's try this. Let's. I don't know yet why that's not working, but let's do the update. Okay, that works. If I build it, okay, sure. That looks like mostly it works. And so if we want to use random to generate a number to guess, so we use the random standard library, or I'm sorry, the third-party library random. We guess the number. Oh, I see. Then we select a random number between 1 and 100. The secret number is this. Please put your guess. Why does it ask twice? Please input. Oh, I see. So first it says guess the number, and then it says the secret number is this. Please input your guess. We do a mutable variable. We do the read line. You guessed. Okay. Uh, I suppose that mostly makes sense to me. So let's go ahead and put this in here. And so we again will say cargo build. Here we go. Cargo run. It's going to say guess the number. The secret number is 76. Please input your guess. 77. You guessed 77. Now, that doesn't make sense. Why would you show the number, then say what's your guess? First, we use this. The secret number is 7. You guessed 4. Oh, I see. Comparing the guess to the secret. Now that we have it, we can compare them. And so what we could do next here is say, I see. So we want to do like a match, basically, expression. I see. So let's make a new string. And then let's let the guess happens. Please put a number in. Here's your guess. I see. And it creates a variable called guess. And now you can go ahead and run it, allowing multiple guesses with looping. And we can do multiple guessing. Okay, well let's try this out. Okay, that makes sense to me. Basically, we're gonna it's like kind of a hot or cold type game. Let's go ahead and do this. And so this would be under the prints. So we can just put this right there, I believe. Right. Let's see here. Quitting after correct guess. Let's just go. There we go. Let's just get to the. Let's just do the whole thing. Let's put the whole thing inside of here. Get the gist of what they're trying to do. And if we look at the code here, we have random. We have some comparison. So we say, let the secret number. So we generate a random number. Put your guess in, and then keep asking someone to guess. And if you get the right answer, eventually you get to quit. So this is kind of a fun game. I like this game. So let's do cargo build. There we go. And then let's say cargo run. Guess the number. We'll say 33. Too small. Okay, let's do 66. Too small. Wow. Let's do. Now I'm gonna. Since I doubled my last one, I'm gonna half this one. So we'll say 66. We'll say plus gonna be 14. We'll say 80. We'll kind of. Whoa. Wow, that's pretty impressive. I guessed the right answer on the third guess. But yeah, I get the gist of this is that the idea here is that we're able to use both matching, which is a cool concept where I'm able to use this ordering library. I'm also able to use a loop here, and the code is very, very clean here. Like I really like the style here of Rust. I'm actually kind of surprised actually that it's this nice of a language. It's shocking. So great progress for me personally this week. I'm going to add star, and then I'm going to say git commit and say adding guessing game code. So yeah, I would say my thoughts here so far are that I'm very impressed with Rust. Of some of the new languages I'm learning, it's shockingly intuitive and pretty easy to work with. And it's an open source language that has a lot of promise. So I'm pretty excited actually to keep working with Rust. So I will see everybody next week that's paying attention, and we'll continue to just go through this guide together and see what we can learn.